Okay, so we are going to begin talking about three variable systems. And our goal will be to be able to solve systems of equations in 3 dimensions. This means 3 variables algebraically. All right, we're going to take a look at this slide and pause here to discuss a little bit. Okay, so how do I solve a 3 variable system? A reminder that a system of equation is a set of 2 or more equations with 2 or more variables. So you're pretty familiar with these kind, okay? What we're going to start talking about is adding a third variable, and that would be z, onto our systems. And then we'll have 3 equations so that we can solve for that third variable. And how do we do that? We're going to use algebraic forms and mostly elimination. So remember up here, each one of these, when we look at these kind of systems, each one of these represents a line, each one of those equations. When we have a third variable with these, each one of these equations represents a plane. So visually, this is what we're looking at. We're looking for where they crossed. This would be examples where all 3 of them don't intersect in any one spot. You'll notice the ones on the second and third one, you get 2 planes to intersect somewhere, but not all 3. So really what we'll be looking at is these kinds, ones where we do have a solution, and mostly we will be focusing on this one right here, where all 3 planes intersect somewhere, and that will be at one point. Okay. So systems of 3 equations with 3 variables are often called 3x3 systems. Generally speaking, you need to find a single solution to any system of equations. You need as many equations as you have variables, meaning you need, if you have 5 equations, 5 variables, you can solve, all right? So if you have 7 variables, you need 7 equations to be able to solve. And using a graph to solve 3x3 systems can be difficult, so we're going to use elimination and substitution to get it down to something that we're more familiar with. Okay, so here are the steps. These problems take a long time. So prepare yourself, take your time, follow these steps, and be really diligent. Watch your signs, be careful. Okay, so here we go. We're going to try this out. Solve the system. And what you want to do is you want to look for a variable that's going to be easy to eliminate. And what will make it easier is if you can find one with a leading coefficient of 1. So I'm going to say, ooh, I see that. I've got a z right here that has a leading coefficient of 1. So I'm going to use that equation. I'm going to use this whole equation twice when I do this. And so we're going to eliminate z because it's going to be easiest. So you're going to do that with the top equation and use this the middle equation to also do the same thing with the bottom. So here's how this will work. I'm gonna copy that top equation, 5x minus 2y minus 3z equals -7. And then the middle equation is the one that I am using because it has the leading coefficient of 1 with the z. So I'm going to use that and write this underneath. Okay, so now what we are going to do, remember we are eliminating, to start, we're eliminating z. So I want to say, all right, if I want to eliminate z here, I'm going to have to multiply this bottom equation, ooh, that's hard for you to see, huh, by 3. Let's see if I can move this over a little. There we go. By 3. Okay, so now over here, we're going to get our 2, let's go, this is still going to stay the same. And the bottom one is now going to be, I guess we'll go back, 6x minus 9y plus 3z equals negative 48. Okay, now we're going to add these together, and this will give us our new equation. I'm going to say that's going to go pink. Okay, so 11x minus 11y, and now we've just eliminated z, that was our goal, equals negative 55. Okay, so now we have a new equation with only two variables. So we've just eliminated one variable. I'm going to call this equation A. Okay, now what we're going to do is we're going to do this again. You're going to use that middle equation that I highlighted because it had a leading coefficient of 1 for z. We're going to use that one and now do that eliminate z with the bottom equation. So again, using the middle, that's not what I want. There we go. 2x minus 3y plus z equals negative 16. And now the bottom one is 3x plus 4y minus 2z equals 7. And now once again, we're going to get rid of z. Okay, so that means I'm going to have to multiply this top equation by 2. So this will give us 4x minus 6y plus 2z equals negative 32. Okay, on the bottom, we're going to just copy because we didn't do anything to that. Okay, we're going to put these together. Okay, so this would be 7x minus 2y equals negative 25. Careful, make sure you watch your signs. You'll be really frustrated if you miss signs. It'll mess the whole thing up. We're going to call this equation B. So now notice equation A and B, now they both don't have a z in them. That's what we were trying to do. Okay, so now that we have eliminated z, now we're going to continue that process, and we're going to take equation A and B, and we're going to eliminate another variable. Okay, so I'm going to go down to here, and I'm going to write equation A and equation B now we are going to eliminate yet another variable. So this means I think I'm going to eliminate y. Looks like a little bit easier. So I'm going to multiply the top by negative 2 and the bottom by 11. Make sure one's positive and one's negative. Okay, so I'll write these down here. So this would give us negative 22x plus 22y equals 110. And the second equation would be 77x minus 22y equals negative 275. All right, now we're going to put those together. So we have 55x. These eliminate. I eliminated another variable, equals negative 165. Okay, divide by 55 on both sides. We would get negative 3. All right, we just solved for our first variable. Cool. So now what you want to do is figure out where to put this. We want to get another variable. Now if I put x into one of these original equations, I'm still going to have two variables. I won't be able to solve for one of those. I want to get it down so I only have one left. Well, I'd have two left. So that really won't work. Oops. So that really won't work. What we're going to have to do is take x and plug it into one of our A or B equations, our pink or purple there, because that has two variables. If we plug it in, x in there, we'll only have one left and we'll be able to solve. So I'm going to pick one of those two. I think I'll do B and plug it in there. So I'm going to use 7x. So 7, and now x, just 7x minus 2y equals negative 25. I'm plugging it into this one, and remember this is equation B. You can plug it into A or B, but now what I'm going to do is just take this and put it here. So then I should be able to solve for y. Okay. So now I have negative 21 minus 2y equals negative 25. Add 21. We get negative 2y equals negative 4. So that means y equals 2. There's our second one. Okay, so now you have two variables. You're going to take these two and you're going to plug them into one of your original equations. It doesn't matter which one. So I think I kind of like, let's just do the, I don't know, the top one, maybe the bottom one. Doesn't really matter. So you're going to plug into one of those, maybe the middle one, whatever one looks easier to you. Okay, so let's say the easier to go, let's just do the middle one. 2 times x. Okay, and x is now, we know it's negative 3, minus 3 times y, which we found out was 2, plus z equals negative 16. Okay, so I have negative 6 minus 6 plus z equals negative 16. Keep going here. Add 12 now to both sides. We get negative 4. Okay, so now I have all three of my variables. All you have to do now is just write this as an ordered pair. So we're going to say, or ordered triple, excuse me. So x is first, negative 3. Then y, 2. And then z, negative 4. And this would be where all three of these planes intersect, is at that ordered triple, or that point in space. Okay, I hope that makes sense. That's, again, here are the steps. Excuse me, here are the steps to solve those. All right, good luck.